Their presence makes you do it.
Recording in progress. So today we're very pleased to have Mario Mercado. Hope I'm saying that right. Been a long time software engineer in lots of companies, focused on Kubernetes and CI/CD pipeline. He's also an AWS Community Builder. So congratulations to that. And has written a book on a practical guide to EKS in Cloud Guru. Oh, and a musician.
Not a book. Not. Oh yeah, I have the piano right here. Not a book. Sorry, Brian, for interrupting you. It's a course. It's a recorded video.
Oh, still very, very cool. So, and I'd love to hear about what your musical background is. But at this point, I'm going to hand it off to you. You can grab the share. Please mute your microphone unless you want to ask a question, and then dive in and ask questions. But away we go.
Okay, I will say we can use Mario's piano as a name that tune for our raffle.
Right. Let me give permissions to Zoom to actually share what I'm seeing on my screen. You guys can see it?
Yes, we can see it.
Yep. Awesome. Well, yes. Thank you so much for this opportunity once again. I'm one of those 21% that is outside of US. I'm in Colombia, South America with O, no Colombia. Yes, I am a musician as well. So the term orchestration, I'm kind of familiar with that in two very different ways. Well, not that different. So yeah, I'm here to talk about kind of a real, very simple example of how to create ephemeral environments or just short-living instances of your application or your stack. So yeah, can you guys see the slides?
Yep.
Awesome. So yeah, let's start talking about, you're gonna take much more advantage of this talk if you are familiar with these services. I'm sure most of you are. If not, that's also fine. I'm gonna try to do my best to explain everything around. But if you are, you're gonna find this kind of, it's a simple solution, nothing really special or anything. Of course, EC2, EKS, this is all Kubernetes, on AWS, VPC, IAM, we're gonna see it a lot, CloudFormation, Amazon or AWS Certificate Manager, Route53, and Elastic Load Balancers, especially application load balancers. So ephemeral environments, what, why, and how? Let's start with what is an ephemeral environment, kind of a very short description in here is basically the ability to deploy applications and microservices in isolation. So they are short-living instances of that. So you can spin it up and down very quickly just to check, just to do some independent testing. Why is that important sometimes? Testing against specific features, components, or versioning. So imagine you are in a team building some cool stuff and somebody needs to code a new feature on the source code, on the source application. If they're using Git, let's say, they branch it and start adding all their changes to their specific branch. And will be nice to have probably an ephemeral environment, a very short-living environment, to spin those changes only with the enough isolation and dependency with the rest of the components, so that they or he or she or can present their application just using their branch. Then they can merge it, and at that point, the environment will simply disappear. It's nice for proof of concepts, for A/B testing, for all of that. It's also nice, and it's also cost effective because the main idea of this is to reuse the rest of the components and have something really small deployed in isolation, so you can actually not have to probably spin the whole thing up, but just that little piece. So how? Again, for making this cost effective, you'll need to have independent components in order to do this very quickly and easy to maintain. Small pieces are also required, again, for speed and for having everything agile. You can have independent components, but those components can be really big. So that's also important that you have small pieces instead. On infrastructure as code, because that will make you easier to simply run a command, push a button, trigger an event that will run that infrastructure or that code or that application behind the scenes and expose that to you with all the components you will need. Infrastructure as code is a great solution for all of these. Of course, in AWS, you have CloudFormation, you can use Terraform. Even in Kubernetes, now that we are landing into containers and all of that, it can be considered infrastructure as code. So yeah. Now let's land all of these concepts, but in containers. So what is an ephemeral environment in a container? Maybe you can deploy your containers in isolation, and those are going to be short-living containers. If you're using ECS, for example, this can be a task with one or more containers running on it. In Kubernetes, it's going to be a pod running one or more containers on it. It can be multiple containers. It will really depend on what is the reach of that ephemeral environment, or what you really need to deploy on isolation. Why? Again, testing a specific container versions. If your CI, let's imagine this is a scenario where your CI/CD environment really needs to build a Docker image. If we are landing to Docker, we push that to an ECR with somehow a versioning as a tag. You can deploy that specific container alongside with the rest of the containers of the rest of the microservices, for example. And then you can take advantage of that ephemeral environment, just deploying the version of the container you'll need. It doesn't really affect the running containers, so you can take advantage of the dependencies, like there is another container in charge of the authentication or the inventory or the orders, and you want to test the resources or some other containers in isolation. You can, since in microservice world, everything is connected and talking to each other a lot, you can also take advantage of that. And again, cost effective, because you can start deploying these alongside with the same orchestration platform you're using. Again, ECS, EKS, Docker Swarm, doesn't really matter. And how? Well, independent networking space for containers, there's a typo in there. You can actually make that independent in the networking if you have things like Calico, or you have configured some other crazy, you have put some crazy configurations in terms of the networking, especially in EKS with the VPC CNI plugin. You can actually isolate that from the rest of the environments. Let's say you have the production environment and the staging environment in the same cluster. If you want to deploy something in there, you can close that enough so it cannot reach the production containers, let's say, as an example. And the container engines as Docker encourage to use infrastructure as code for repeatable deployments. Kubernetes is not the exception. Well, so for the example I have, let's review the architecture. But before that, any comments, any questions, something in there, or we are leaving those for the end? I'm also happy if you guys like stop me and want to add some comments or ask some questions. I'm happy with that.
Yeah, we're not a very shy group. People will absolutely jump in.
Yep.
It looks like, yeah, for sure, it will.
If folks are shy and want to post in the chat, we will make sure that whatever you post does get brought up as well. So we just want to accommodate everyone.
Awesome, thank you. Okay, so let's take a look of the architecture we have in here. And all of this is in a GitHub repository. I'm going to be sharing in the chat after I close all of these windows. So we have the end user app here. We have the end user. We are going to give it a domain name, DNS, very famous these days because of the Facebook outage. but we're gonna give it a DNS to an application load balancer, of course, SSL, terminator, and all of that. And the AWS load balancer will be controlled by the AWS load balancer controller on our Kubernetes cluster. I'm gonna deploy that. And the DNS will be created by the external DNS. Now, these two, the AWS load balancer controller and the external DNS, are really open source projects for making easier the automation around Kubernetes. And the AWS load balancer controller one for load balancers, and external DNS will support Route53 for creating DNS records in there, but it will also support other DNS providers. So depending on which environment we're talking about, let's say the end user is actually a QA engineer on the team, they can be split into, let's say, app-dev, and that will give you that will drive you to the dev environment, where you're going to have the pod, an ingress that will drive the controller and all of that. This is all deployed with Helm. Helm is this packaging system for Kubernetes that allow you to, all those big YAMLs and all those components on Kubernetes you need to deploy. This will help you to replicate all of that. This is one of the infrastructure as code. We want to see it in that way. And we can continue deploying this Helm chart, doing more releases of this Helm package, so we can create more and more environments. One of the ability of Helm is that we can spin everything up. In this case, is the pod, which has the container through a deployment, whatever, the service on it, the ingress with the DNS on it, and we can take all of that and deploy it as many times as we want in our cluster, and then simply wait for DNS to replicate all of that, and the end user will be able to get this. Actually, on our company, we have something similar to this, where the developer can start developing on their own feature branch, and they can request that their branch is actually connected to a CI/CD pipeline that will update their own ephemeral environment. Once they are done, these branches merged into the trunk, into a develop, into a master, whatever. And that environment, that Helm chart, will simply go away. So yeah, this is basically the architecture. We'll try to install everything we're seeing in here, and it's demo time. Normally on demos, nothing happens. Everything works great. Nothing really fails. So I'm just putting that aware. Let me go to, I already have, just to spin things up. This is my AWS account. I already have a Kubernetes cluster in here, an EKS cluster. So let's go to the, well, before that, this is the repository I'm going to be using for the whole demo. So it's hopefully documented. And yeah, we're going to start going through all of these.
Can you put the link to that into the chat, please?
Sure, absolutely.
Thank you.
Let me see, how can I open the chat here? There you go.
Awesome, thanks.
Okay, no problem. So this is the repository. This is all we have in here. I already created the cluster. If you have your own Kubernetes cluster, that's fine. There are a couple of things you might want to change. One is the region you are. I'm currently working in Ohio. There are a couple of files in the documentation you can find where you have to change it. And the other one is that for running this successfully, you will need a hosted zone on Route53 with a valid DNS. Let's say, put in that terms. First, let's see that I'm actually connected to a cluster. Yes, I am. So let's go very quickly and let's install the external DNS plugin or extensions. So you're gonna find that every folder has a run.sh command or create, something like that. This one will have everything that it will need for actually deploying it. Let me actually put it run while I explain what it has. And you're gonna find this pattern in the rest of the repository. So we are creating first an IAM policy for giving permissions to external DNS to create records to a Route53. We use EKS CTL to create the IAM role for service account that will actually create a service account on Kubernetes and an IAM role in our AWS and bind them up. So our containers can take advantage of that role. And finally, we just simply installing the YAML file that has all the Kubernetes deployment stuff for external DNS. This application is actually listening to services or ingresses with the DNS on it. It has all documentation of that. You can find it on GitHub. I'm sure some of you probably have heard or use it. It's really good. It's really nice. So it's running here. And after this one finishes, we're going to start our AWS load balancer controller. Again, the same run strategy, but in this time we are using a Helm chart, the public one for them. Yeah, basically the AWS load balancer is an open source project developed by AWS, and they or the controller basically is also listening to services or ingresses in your Kubernetes cluster to create the real load balancer that represents all of that with the, if it is an application load balancer with all the target rules, with the target groups and all of that will be handled for you. So you don't really have to worry about provisioning load balancers and all of that. It's very broadly used on EKS especially. So if you haven't got the chance to look at it, I highly invite you to review it. So it is creating a couple stuff. Right now it's going through the EKS command, the EKS CTL. And this one is creating that IAM role for us and the service account in the Kubernetes cluster. It could take, normally doesn't take that much, but it takes a couple of minutes. Once we have all of that, then we start looking at the application itself. So while this goes, I'm gonna take advantage, and after we install these two applications in here, which I guess I should have installed before the show and tell. There is a Helm chart in here with a simple Nginx application. This is just an Nginx splash screen, the one that comes with the software. So here are some things that you might want to change. This is my personal DNS domain name. If you want to run this lab along, you have to change in here to the one you're going to be actually using it. Here is one place, and in a minute, I'm going to show you another place. And if you're creating the cluster, for example, with this command, this is EKS CTL. Again, this is an open source tool that allows you to easily, very easily manage your EKS clusters. And in cluster, here's something you might want to change as well, is the region you're using. The rest of stuff you can leave them as they are, or simply change them. If you want another CIDR, for example, another AMI for this one, that's also fine. I also take the opportunity to mention that in this cluster, we are using BottleRocket. This is the operating system optimized and created by AWS only for containers. You cannot actually SSH into it because it doesn't really have that. It doesn't really have an SSH daemon or anything. The way you interact with the cluster, with the operating system, is through a container administrator that will be able to run all of that for you, or through an API that they also explain how to use and all of that. So external DNS is done. Let's go to the AWS load balancer controller and let's run it as well. Any questions so far? Looks like no. Here's something in the chat. All good there. Thank you, John. So, and whenever we finish this, if time allows me, the repository comes also with a delete .sh file that will kind of help you to delete everything you have in here, you have created for the lab, because we know that AWS doesn't really forgive, and they really love charging you. If you leave your stuff running, I mean, they won't tell you. They would just start charging you there. So just make sure that you delete everything in order, because there are some things that needs to be deleted. For example, you need to delete all the applications, all your sample or your microservices, Helm charts or Helm releases before deleting the external DNS or the AWS load balancer controller. Why? Because if you delete those first and then you delete the applications, I'm sure you're gonna finish with stale resources in there, because there won't be any controller or application making sure that your records or your load balancers are actually deleted. So make sure you drop everything that belongs to you, and then you can start removing all the controllers and all of that. AWS Nuke is really a good solution in there. If you wanna actually test that, that would be really cool.
We were
Just
having
make
a
sure
conversation about that at the beginning, so I was just throwing that in there as a snarky side comment. Sorry.
That's fine, but it will actually work.
Yep,
Just
totally.
make sure your AWS profile environment variable is not set to the production one. Just make sure of that. Double check and triple check.
But if you do it, please let us know the outcome and how that production support bridge goes, because I would be thrilled to hear about it.
Oh.
That's where you really are going to test your RTOs and RPOs.
Right.
So any questions so far? Any comments?
I think we have a comment here in the
chat.
Yeah.
Yeah, so John, he's saying we used to have issues with AC inserts. We had generated the we will DNS validation, and it will generate records on Route53, but it wasn't tracked in CloudFormation. So trying to delete the Route53 stack will throw an exception about the records remaining in it. So basically, what you have in here is that the validation DNS record that ACN created for you in order to validate that certificate wasn't allowing you to delete the Route53 stack, the hosted zone or hosted zones. That's what it is, right, John? Did I get it correctly? Awesome. So yeah, that normally happens also with S3. I'm sure there is another service that doesn't allow you to do so. You basically have to empty all of, like in S3, all the buckets, Route53 in the hosted zone, like all the non-default records before actually having to delete those. That's actually a good point. I guess that you have to have that order of deletion, like first the ACM certificates, then the content of the Route53, and then the hosted zone itself. That's always important, having an idea to having an idea about how my resources are preventing themselves to be deleted, so that I can actually address those. It's actually a really good point. DynamoDB, for example, you can delete the whole table without worrying about any single item. And that's something we hopefully are going to do in this demo as well. So thank you, John, for that comment. Okay, we have the AWS load balancer controller, and let's start with our Helm chart. This is our sample application. This is just a deployment of an Nginx image, super simple. It comes with an ingress, and here we are building our DNS. So the app is like hard coding there, hyphen, and the name of the namespace It's important also to notice that we are going to be creating one namespace per environment. You are free to not to do so, but in this example, we are. And then we are getting the base domain, the one I showed you in the values.yaml file, this one. We are injecting it in here. So depending on the namespace we are actually using, that's going to be the URL that we have. Same thing for the service is super simple, just exposing as a node port the deployment. Let's go then and start creating all of these. Let's go to Helm. And here we have, again, a run.sh command. We are first creating the namespace, and then we are running an upgrade. If it doesn't exist, let's simply running install. I just learned like 2 days ago that you can add another flag in here, like create namespace if it doesn't exist. So this line is actually not really needed, but anyway, that's the way it is. So we are passing as a parameter to the bash the name of the namespace, and that will create a release with that name and put it into the namespace we just created. So let's try to do that. It shouldn't take that long. So run.sh, and let's call this like def as the one in the example. So the namespace def is created. The sample app is also created. It will take a couple of minutes, and here it is. So great. All these comments are coming from the notes.txt that also take advantage of the templating engine on Helm. And it's actually putting us the recording here. And this is the demo part. So if something fails in here, it's because it's a demo. Let's copy this one up. And let's actually verify that. Let's check 2 things. So we give some work to the external DNS and to the AWS load balancer controller. So let's see if that actually created a load balancer for me. It doesn't provision immediately. It takes, there it is. So it is provisioning. It is an internet facing load balancer. Of course, you can make it whatever you want. In the AWS load balancer controller documentation, you can find how to actually make it internal. And in the listeners, we're gonna find that it's using the ACM certificate I had before. I created that for my own DNS. The controller actually identifies if I have that certificate created that matches the URL I'm trying to create, and it will simply add it to the rule in the load balancer. If we take a look at the rule, it will say that the host app dev mariomercado.com, it's actually pointing to a target group that it also created. You can see the Kubernetes, the namespace name, and the service name with some tokenization they add in there. It's an Nginx application. So that's that. The controller is working. It has all the IAM permissions and all of that. And let's go now to Route53 in order to see if it already created our DNS record in here. It should be pointing to that load balancer, or I don't really know if the load balancer needs to be fully created for that. I don't remember that. I don't think so. Yeah, so here it is. Let me actually close this and expand this in here. So this is my application endpoint. It's an error record, and this is the load balancer. It's just been created. Let's actually go back to EC2 and take a look whenever that one is already provisioned. The load balancer takes like 2 or 3 minutes to provision, so keep that in mind. There you go, active. So let me go copy again the URL, and if DNS cache or replication is not against me, we're gonna be able to see the welcome to Nginx page. This is internet facing, you can actually hit it. So great, we could create with just one command the dev environment for this specific, very simple application. Let's go and create another one. Let's create the run QA environment, let's say. It's deploying exactly the same thing, create a separate namespace. And there you go. This is my new URL. Let's go back and take a look what it did. On the listeners, we now should see another rule added to it. Here it is. And if we go to Route53, let me actually open that in another tab. Let's go to hosted zone. It's not created here yet. It should take a couple of minutes, yeah, it should be really quick. So at some point it should come. It's not in here yet. There you go, 16. Okay, so here it is. Now let's try to open that one up. There you go, another instance of our application. So that was very simple in that matter. Nice. Any question in that? That's really, of course, for this demo, it's not really the whole thing, but for the architecture, that's what we had. Actually, let me go back to where are the demo. This is everything we've been created. We created the AWS load balancer controller, external DNS, and we, of course, we had to have the hosted zone and the certificate that catches all of these as with its wildcard. But we are simply running that command. We can create an instance of all of these, and we can start creating more and more and more, and simply just going crazy in there. Any questions so far?
What are some general practices you might recommend if outside of these, dev and QA boxes, you needed to talk to different, maybe databases, maybe something like DynamoDB? How do you kind of keep track of that? Or if you needed to share a DynamoDB for dev and QA, but not share it for production, any tips or tricks for how to manage some of that?
Yes, and I'm actually super glad that you brought that in, because that's part of that's in the next step of these demo. So yeah, in real world scenarios, this is just an Nginx application. You're gonna have tons of dependencies on it. It can play with the service name. If you have other containers running in the same namespace, you can deploy one container into it, and the service name will help you as, or will work as the service discovery if you want to access another API, for example. In terms of databases, it will actually depend. If you're in DynamoDB, you can create a DynamoDB table for that specific environment. If you are in MySQL, SQL Server, MongoDB, you can create a database and see that with the initial data set or the required data into it. It can go as far as you really want. The only thing you have to keep in mind is that, and this is where when we are architecturing microservice solutions as a whole, we also need to have in mind that what are the dependencies for my own code of my own microservice I'm working on. Why? Because if that microservice requires a very specific set of other microservices, I'll need to deploy those as well with my own code. So if you keep that in mind, I'm sure that you're gonna scale your application or your solution with like tens of microservices, hundreds of microservices. But if they are well isolated and well discrete, you will be able to take advantage of these type of solutions and improve quality, just testing things in isolation and all of that. One service point to different deployments for dev and QA instead of adding a DNS record to probably injure changes of here. I mean, yes, you can. And the load balancer control will allow you to point your application using the same DNS record, but with another path, like my app.marioamerica.com/ and the feature branch if you want. You don't have to actually create a DNS record. You can actually just take advantage of the load balancer controller, and it will create a path to that specific one. So that will actually help you with cores. a lot. We have all that issue all the times. So if you have the same DNS, but splitting your applications, your APIs, all of that by the path of the whatever you want in there, that will also help. It doesn't really have to be the root of the DNS. Okay, so let's go back. The demo didn't fail, hopefully, thank God. So now, for that very specific question about DynamoDB, let's expand our application. I have also in the repository, it's a simple microservice that creates records. I just made it. I just called it the services API. You can register AWS services to it. What type of service is that one, and if it offers a free tier or not. So Infinidash is one of them for sure. On this API, we're gonna have the dependency of a DynamoDB table. It doesn't really have to have any data on it, it just need to exist. In order to do that, we can take advantage of CloudFormation. We can run alongside with the Helm command, a CloudFormation template, well parameterized, that allow you to create that DynamoDB table for you. But there is another open source project the AWS container team is being offering, and so again, it's open source, and it's called AWS Controller for Kubernetes. I don't know if you have played with it. It's not really production ready yet, but they have some services for it. So for ACK, you have individual containers for each service, like for S3 buckets or for DynamoDB tables. In fact, this is the GitHub repository for that. They explain you all of that, and they say that they have service controllers. So it's a controller for service. Let's go to the services that it supports. And since this is, I'm kind of sure any of these are ready for testing for production yet. Everything is in preview or released or proposed, like ACM, for example. DynamoDB is released and in preview. We're going to take advantage of this one. Amazon ECR, Elastic Container Registry, is also in preview. So you can start taking advantage of all of these. And we can maybe translate this on a kind of CloudFormation inside Kubernetes. Basically, what the container will do is to listen custom resource definition or CRDs. These are custom type of objects that you can install in your Kubernetes cluster. And you can put something on it that will understand those type of applications and simply, or objects, and do whatever it needs to do with all the configuration you have in there. So in this case, the controllers will see those objects and will create in AWS the resource that will represent that configuration you have in there. Again, that's infrastructure as code. It's always nice to have that ability inside Kubernetes, so it will allow you to connect, like in this example I'm going to show you, the AWS resources with the deployment itself. In this case, we're going to be deploying our API, and it will come with the, hopefully, if it doesn't fail, it will come with the DynamoDB table on it. So let's go to the ACK folder. You're going to find two folders in here. The first one is the ACK DynamoDB. It will have, and actually let me put it to run so we could take advantage of it. EKS. Yeah, so cd ACK, here it is. So let's run it. So basically what this is doing is taking advantage. It's following the same documentation they have in there. We are creating an IAM policy, allowing the controller to create, delete, and manage the tables in DynamoDB. We are creating that for it. And then we are installing the Helm chart with the controller on it. The version will be like 0.0.6. Again, this is not really for production. I'm just showing this because this is community open. Everybody can actually jump to Monday calls they have discussing about the roadmap and including other services and improving their development. All of these, again, developed by the AWS team, will help us to define inside Kubernetes those objects that we'll need for databases or any other resources the application will actually need as a dependency. It's very similar, very frequent, of course, to find applications that will require databases. Any questions so far? We have a command running in front of us.
I have a question. It's sort of I'm having trouble formulating the question, but when I think a lot of my infrastructure as code is going to be done with something like Terraform, and I know that Matthew, who is a CDK guy, just stepped off, but Helm is all, it feels like I want to ask some question about the intersection between Helm and Terraform, because they're both sort of orchestration engines, and I've always been just a little fuzzy. So I'm sorry that's not a coherent question, but if you can find a question in there someplace.
So let me try to help you define the question. It's like, what are the touch points or the why are Helm and Terraform similar, and why those are like two different products?
Sure.
Like that. Yeah. Okay, so Helm is very Kubernetes specific, and the extension of Helm really is what you have on your Kubernetes cluster. Helm by itself doesn't really know anything about your architecture or what you have on your container, on your cluster. It will basically package your application, and it takes advantage of a template engine based on Go, the programming language. And it will help you to deploy the same set of Kubernetes objects, all of those YAMLs with parameters, and replicate that or deploy that multiple times in the same cluster or multiple clusters. What actually creates those other resources that it's kind of the touch point with Terraform or CloudFormation, for example, is the controller or the plugin you have in there that will be able to listen those events or to review or to understand those objects you are creating through Helm in order to create something that represents that object in the cloud or anywhere else. So I think the main difference is that Helm is really Kubernetes YAML packager, and the rest of the logic, if I don't have installed on my cluster external DNS or the AWS load balancer controller, Helm will just create those YAMLs and nothing else. The cluster will be like full of things that doesn't really represent anything. But with Terraform, you're actually interacting with the representation directly to the cloud environment. Did that make sense?
Yep, thank you.
Awesome. There's something in the chat. Have to jump. Okay, thank you, George. Okay, this is done. We have the ACK DynamoDB controller up and running. Of course, we use iron roles for service account in our EKS cluster to give it permission to actually create and delete and manage DynamoDB tables. So in the same ACK folder, you're gonna find three sample microservice, three folders in here. Actually, let me go to in the terminal. Let me go to CloudFormation and let me run it. And I'm gonna explain what that one has. This one will create as a CloudFormation the IAM policy for my application. So my application will require permissions to access DynamoDB, to read objects, to scan, to run queries, to create items, all of that. That's the policy I'm giving to my microservice. That's the only thing I'm doing in this folder. In the app folder, you're gonna find the application itself with its own Docker file. This Docker file was already built and I pushed it to my Docker Hub site. The Helm chart will have those. If you want to build it, if you want to push your own, you're always welcome, but that's already public, so you can take advantage of that. And in the Helm folder, again, we find a create .sh, a command that will help you to install everything. We create the iron roles for service account, and then we simply install our Helm chart. That's all. We are not talking in here anything about DynamoDB tables. So let me go back to the Helm folder. Here it is. So I'm gonna run create, and this one is like the old one. I need to specify the namespace or the environment. I'm gonna make it develop. I'm gonna let it run in. On Helm, in the templates folder, we're gonna find all the YAMLs or any other resources that we're going to be including on our Helm chart. There is a normal deployment. There is its service. Here's the ingress, of course, the service API, and more or less the same logic as we used before. The node text, it will actually show us that URL when it finishes installing. Let me get this down here. And the important one for us in this demo, or the different one, is the DynamoDB table YAML. As you can see, basically Kubernetes, we can see it as a huge API. And that API is extensible depending on what plugins you have in there, if you will. We have this API after we install the controller itself. And it's kind of a table. We put the name of the table in here, and we define the table, the DynamoDB table, as we really want it. I'm just creating a very super simple DynamoDB table in here just for the demo. Okay, it already created. Of course, it will create that load balancer. It will create the target group pointing to my application, all of that. Let me actually copy this. But something that we need to see also is this DynamoDB table. The namespace is developed, so we should see a develop-services DynamoDB table in there. Let me actually go there. For some reason, this is super slow today.
It was that confidence you had that no demos would go wrong. I think that was just a slap in the demo god's face.
You've displeased the demo gods.
Right, they are super happy about it. So here is my table, develop services. It was created through CloudFormation. The controller was the one actually creating it, and then it's empty. That's it. In the load balancers, let's actually reload. Listeners, we should see another host in here. There it is. So services API develop my domain name. So this is an API. I don't really know how to use it. I put the documentation site in here as well. It's in the Git repo. So good job. It has two endpoints: create. It will receive an object like this, and it will have a list object in here as well. Let's actually try to test that. Thunder client. Let me create a new request. In here, let's do let's grab this guy in here. And let's hit the list endpoint. There you go, nothing in here. The repository comes also in the app folder with an example of the payload. A service group is not 2020. So let's make this a post. The other endpoint was create. And let's shoot this as container service. Let's hit it create, and there you go, inserted. If we go here, actually, let me create another request. Let's do the list. That's expected. If we go to the other request, let's say RDS is a database service, and yes, it offers free tier. And here now we have the two objects. That's not really the point. But if we go, of course, to the table, now we're gonna see the two objects in here. Of course, if I go ahead and create another environment, let's say called test, it will do exactly the same thing. It will create that DNS record. Well, not the DNS record because, the DNS record, the target group, all of that, bind it with the load balancer, create the IAM permissions for this table in specific, and create that other table as well. At some point, it should come up. Any questions so far? We're almost done in here. There's something in the chat. Okay. Great. Our new endpoint. I'm not really gonna test that one. I don't want to mess with DNS. They really love catching me. Here's our endpoint. It will work exactly the same. And yes, there's a refresh button. Here's our new table. If we go ahead, Helm organizes like in CloudFormation, in stacks. Helm organizes the deployments as releases and inside the normal namespace, for example. So if we do an ls for list and in namespace develop, for example, we're gonna find that we have, get rid of this and run the command again. We have one release in this namespace called services API develop, in the namespace develop. So I'm gonna delete it, develop. And when I delete this, it will, of course, drop my container. The application won't be available again. It will clean the rules in my load balancer. Yeah, the service API develop is no longer in here. And it will also delete the table for us. And again, that table had some items in there. We don't really have to empty the table before deleting it. So yeah, that's basically the demo. That's yes, different demo, same failure. The main idea of this project is, again, to have something to show that the idea is possible, but you can actually expand these depending on your use case, depending on what your microservice will actually need, depending on what databases you have to put in place. I'm sure, and I guarantee you, in real life, there are some places where you cannot replicate these, otherwise you have to replicate the whole stack, and that will be like super expensive. Better to run that locally, but there are some cases, there are actually a lot of cases where you can actually take advantage of the idea of an ephemeral environment. I'm just showing you in here that for almost everything, we can say, there is a controller or an operator in Kubernetes that will help you, or that will tool you to create these environments more dynamically and bind them more to automation, and just simply forget about them because they are going to create by themselves. They are deprovisioned. They will clean everything for you. Yeah, that's kind of it.
So,
greetings from Colombia, Cesar. Cesar, where with you on BSI? Glad to see you around, man.
So we'll take questions. I do want to just mention to folks in the chat, I put a link to a post-meeting survey. We're always looking to get feedback on how we can improve and so on. And we still do have the raffle. Raffling off today one of our lovely mugs. A question I have though, if I could, how much of this is sort of reusable? So suppose I had now another microservice that I wanted to test. How much? Because I mean, there's a lot going on and there's a fair number of files, but I'm guessing that there's probably a a real subset that I have to change for a different service?
Sure, absolutely. So how much, it will really depend on how your other microservice will actually be defined. If this is if your other microservice is an API and requires a DynamoDB table, you can use almost everything in there. The only thing that will change is the endpoint. And well, if you're running this on Docker, it doesn't really matter how you develop the application. Something to keep in mind, and I think that's part of the microservice spectrum, is that, and I call it like build once, deployed multiple times. Why? Because you can build your Docker container, and you should build that by thinking about, okay, my application shouldn't have anything hard-coded on it. Everything should be configured from the outside, either that's through environment variables, through config files, through database tables with configurations and settings on it. If you do that, you can start taking advantage of the same set of your solution around the automation to create that ephemeral environment. So again, and we have something on our company that I saw once in a video with this series in AWS called This Is My Architecture. Expedia has a really nice one that they have this product. I don't remember if they mentioned the name, where the developers can jump into the UI or something and configure, okay, I want an application, it's a container, it's a Lambda function, whatever. It's written in Node.js. So they configure how they want their microservice, and then you just simply receive the URL of the Git repository. And they will leverage everything for you, connect all the pipes in, let's say, Jenkins, code pipeline, anything. And you just have to start coding. When you push your code, all the automation will be there. So if in your company or your projects, you define a standard of how the microservices more or less looks like, you'll be able to group them and simply say, okay, if I'm creating this type of microservice, I know this type of automation will help me to create the ephemeral environment.
Anyone else got a question?
Expedia team, yeah, that's the one. It's really great. It's for the DevOps call, Torres SREs, and all of that automation for everything. That's a really good video because that one actually, for me, it inspired me to start thinking about that and provision the developers with all the tooling they will need for putting their code, even app, to production.
Okay. One of the things that occurs to me is that there's, as there usually is in Amazon, there's multiple ways of doing things. And I'd love to do like a panel discussion, or maybe like a cage match between EKS, Terraform, CDK, and maybe just, CloudFormation. I think it would be, I don't know. I think it might be interesting to sort of have the debate.
Sure, absolutely. That will. I think at the end, in a podcast, I think somebody asked me, how do you decide which container orchestrator to use, especially in AWS? If you go to Kubernetes or if you go to ECS, both have pros and cons, of course, but I've worked with teams that use both. So, I mean, they are simply saying, okay, we know that Kubernetes can do this and not do that, but ECS can do what EKS cannot on some spaces. So we deploy to both of them. We have both type of clusters. I think it will apply the same for CloudFormation, Terraform, these type of controllers, operators inside Kubernetes, and any other solution in there. I think at the end of the day, the debate will be nice to have, because that will help us to identify what are the weak points for each tooling. But it will really depend at the end if you are not using 100% of the tool set or the feature set of each of the applications, you can start even overlapping and just taking one path and probably in the other in the future switching to the other one. It will really depend on the team's desires, how comfortable they are. If you already have that, this is something that happened to me. We have on our on one of our AWS accounts more than 500 stacks on CloudFormation. And we have like a template of templates in CloudFormation that was like 3 years ago, 4 years ago, I don't remember. CDK was on its early stage. Then it came with CDK and people start loving CDK and all of that. And then we say that, okay, we have all of this work done on CloudFormation templates like naked YAMLs or JSON files. Now it came with CDK. What can we do? Is CDK suitable? Is CDK good for this? Is CDK good for that? And now we have some applications being deployed with CDK, some of them with SAM, some of them with the serverless framework, and we still support those old YAMLs and JSON files on Kubernetes, on CloudFormation, sorry. So yeah, that's a really good debate. I'll be more than happy to participate if you ever create it.
Okay. Yeah, we're certainly not going to come with find the right answer, but it might be entertaining.
Sure.
So I have a trivia question for the mug, unless you have a trivia question you'd like to ask. Okay, so the way we do the trivia questions is we ask the question and then type the answer in the chat, and the first one to get the right answer wins. I will say I will endeavor to be able to ship the mug outside the US, though that, if that's the winner, though that may take a little bit of extra time. So in honor of the new movie Dune, what's the, yes, Chris is shaking his head. What was the Freeman's name for Paul in the movie? Chris, that's not quite the right answer.
Oh, it's not? Oh, okay. It doesn't matter if I answer right away.
Victor, that's great. And Victor, I'm curious, how do you pronounce it?
I think it's pronounced Muad'Dib.
Yeah, I've also heard it as Muad'Dib.
Muad'Dib, yeah, I think that's correct. I listened to the audiobook a little while ago, and I think it is the way you pronounce it. So
okay.
Depends on which movie you watch.
I actually haven't gotten to it yet, but yeah, it looks pretty cool. And Muad'Dib is just it's just pleasant to the mouth. Muad'Dib, it makes me smile. So so Victor, send me your postal address and I will get the mug out to you.
Nice.
will do. Thank you so much.
Yeah. Other questions? Okay, well, thank you so much. This is fascinating. Just goes to show we continue to have great meetings with amazing speakers. So thanks everyone. We've got a meeting, our meeting in the next 2 weeks. It looks like it may well be a follow-up deep dive from our presenter from last time on more about IoT, which is an area we haven't covered, very much in the past. So it's interesting to go there. But we do see what people are asking for, in the survey for things. And I'm just going to make sure I've got it. And Victor, I should know this, but remind me your last name.
Laura, L-O-R-A.
Okay. All right. Well, thanks everyone. And we'll see you in a couple weeks.
Have a good night,
Thank you,
folks.
guys.
Bye.
Bye.